Hi, my name is the business challenges resolved by modern data warehousing and cloud scale analytics. We'll have a detailed conversation about common challenges, typical data warehousing patterns, and how Microsoft Azure provides you with scalable solutions for data warehousing and cloud scale analytics. As a presenter, I encourage you to think about these scenarios applied to your own or your customers' business problems and how you see the potential of how you can help providing better insights through cloud scale analytics. I appreciate and welcome questions at the end of the presentation in the question and answer section of this presentation.
In this session, we'll cover a set of topics that will increase your understanding on how to build modern data warehousing and explore different patterns. Specifically, we will cover the sections why build a modern data warehouse. We will cover the session building a modern data warehouse. We also will have a look into advanced analytic patterns and in general the evolution of cloud scale analytics on Microsoft Azure. Let's start with chapter 1, why build a modern data warehouse. Digital transformation and data estate modernization, it's the topic of the day and for a good reason. It's here to stay. It's a phenomenon that is actively fueling both the success and the failure of every organization. Some organizations embrace a digital transformation journey and feel excited about it. And we see organizations are reaping real, tangible rewards. The positive disruptions are truly amazing. But we also acknowledge that for some, the whole topic of digital transformation is causing tension. There are legitimate concerns about getting digital transformation right, and in truth, future success does depend on making this transition. So let's step back a moment. There are some things that can help demystify the whole topic a bit, to help you think about it differently. Positively, 91% of business leaders see digital transformation as a way of sparking innovation and finding efficiencies. Also, 68% say digital transformation is increasing profits. But on the negative side, there's also a lot of people saying that they must offer digital services or become irrelevant. And this is one of the big concerns companies have. 60% of business leaders say they have less than 4 years to complete a digital transformation or they may go out of business. So time is counting. So let's spend a moment identifying what prevents companies from capitalizing on that data growth. Historically, they have been challenges with on-premise solutions. Data typically exists in silos. There are all sorts of data coming in, stored across databases that power the applications or lifeblood of a company. Data from sensors and devices, external data, sources from media or more. But harnessing that data is difficult and costly. Furthermore, connecting the data in ways that drives deeper insights poses even greater challenges. Performance constraints. On-premises systems reach capacity. Customers are having to make strategic decisions about how to scale and how to do it cost effectively. And at the same time, it takes sometimes a lot of times for customer to order new hardware, to bring them in place. Every 3 years they have to start again. It takes a long time to get the hardware, etc. The next topic is complexity of solutions. Over time, companies have adopted a variety of products or solutions to solve specific business needs. They now find that they have a diverse set of tools on-premise and in the cloud, all with their unique tool sets and cost models, and skill sets requires to use them. It is hard to scale up and scale these offerings for the whole company to take advantage of. And costing is no longer transparent. The invoices has many line items to manage, and some procurement departments are simply not prepared for switching from a typical on-premise bill to a cloud bill. This all comes to rising costs, scaling up and adding hardware, paying for multiple tool sets that have some overlapping capabilities but lacking the scale or ubiquity to do more than a purpose-driven task well. And hiring resources with the specific skills needed adds up. And suddenly, companies looking to get ahead and maximize ROI with data are finding it challenging to harness it for transition. To derive real value from your data, you require a comprehensive platform with familiar tools and a robust ecosystem of partners and ISVs to deliver the solution you need at cloud scale. One hub for all data is something you should aim for. This is one of the most significant pain points we hear from customers. How can I get access to all of my data internally and externally to my organization? Each system needs its own database. That is true. Microsoft Analytics Solutions is able to connect to those data sources and bring the data into a cloud-scale data warehouse solution for deriving insights from a variety of data sources. Unlimited data scale. Not only can Microsoft Solution process these diverse types of data, it can do it at scale without constraints typically associated with existing on-premises solutions. Familiar tools and ecosystem. And you don't have to hire a number of specialists to manage a niche tool. Microsoft offering provides familiar tools and ecosystem to help you leverage your investment quickly and have a relatively small learning curve. Lower TCO. The benefits noted all accrue to the lower TCO. Across all organizations and industries, common use cases are identified by the need for 1. Modern data warehousing, the ability to integrate all data, including big data, with the ability to reason over data for analytics and reporting purposes, and reason over data independent of its location or structure. At the same time, companies want to aim for advanced analytics. They go beyond the area of reporting and driving analysis and turn your wealth of data into the ability to predict what happens next. And lastly, real-time analytics. Capture, store, and analyze data in real time or near real time to drive real-time dashboards or even to drive IoT business, etc. So let's have a detailed look on how we go about building a modern data warehouse. Across all organizations and industries, common use cases are identified by the need for modern data warehousing, the ability to integrate all data, including big data, with the ability to reason over data for analytics and reporting purposes. One hub for all data. This is one of the most significant pain points we hear from customers. How can I get access to all of my data internally and externally to my organization? Each system needs its own database. That is true. Microsoft Analytics Solution is able to connect to those data sources and bring the data into a cloud-scale data warehouse solution for deriving better insights from a variety of data sources. At the same time, unlimited data scale is very, very important for customers. Not only that Microsoft Solution can process these diverse data types, it can do it at scale without constraints typically associated with existing on-premises solutions. Familiar tools and ecosystem. And you don't have to hire a number of specialists to manage a niche tool. Microsoft offerings provide familiar tools and ecosystem to help you leverage your investment quickly. That means the learning curve typically is very low. At the same time, the benefits noted all accrue at a lower TCO over the time. In addition to that, customers have the need to integrate their existing big data solutions, and more customers think about what Microsoft is calling PaaS services, platform as a service, for a pay-as-you-go model. When we think about usage patterns that customers are using today to maximize the value of their data and become a data-driven organization, a modern data warehouse lets you bring together all your data at scale easily to get you the insights through analytics dashboards, operational reporting, or advanced analytics for your users. The process of building a modern data warehouse typically consists out of several different steps. First, data ingestion and preparation. Here, Azure Data Factory could be one tool of the choice for orchestrating and generate the data flow. Second, data modeling, making the data ready for consumption by analytic tools. Here, the Microsoft Azure Synapse Analytics Data Warehouse is the tool of choice because it's a lot faster and costs a lot less than other cloud providers in the market. And thirdly, providing access to the data in a shape format so that it can easily be consumed by data visualization tools. Here, Microsoft Power BI is one of the tools of the choice. At the foundation, customers can build a data lake to store all their data and different data types with Azure Data Lake Store. Once you're using Azure Data Lake Store, where you ingest your data, all of your data, you get rid of several things. First of all, you get rid of the migration nightmare because data are not changing anymore. There might be an additional format, but you can use Azure Data Factory with data flows to easily generate this new data format. But the tool, you don't bind the data to the tool at the other side. You import all your data in different zones. You live with some parts of redundancies, but you have all data at hand in the format you need it. To ingest data into the Azure Data Lake Store, customers can do code-free with over 90 data integration connectors with Azure Data Factory. Data Factory empowers customers to do code-free ETL, ELT, extract, transform, load, or extract, load, and transform, including preparation and transformation. And while a lot of your customers are currently heavily invested in SQL Server integration services, packages, SSIS, they can leverage these without having to rewrite in Azure Data Factory. Whether the data is on-premise data sources, other Azure services, or other cloud services, customers can seamlessly author, monitor, and manage their big data pipelines with a visual environment that is easy to use. Another option for data preparation, of course, is Azure Databricks, the rising star at the big data heaven. To shape the data formats and prep it using a notebook in various different formats, making internal collaboration on data more streamlined and efficient. The Azure Databricks is a native Azure service and can be used from the Azure portal. At the heart of modern data warehouse and cloud-scale analytical solution is Azure Synapse Analytics. To ingest data, customers can do so with Azure Data Factory, and Azure Data Factory brings everything into the data lake, and then you have the possibility to connect your Azure Synapse Analytics data warehouse to the data lake and get the data into the data warehouse by using the native connection of Polybase. Azure Synapse Analytics is a modern MPP approach. It's very scalable. It's up to 14 times faster and costs most of the times 94% less than other cloud providers and other cloud data warehouses. Power BI enables customers to build visualization on massive amount of data and ensure that data insights are available to everyone across their organization. Power BI supports an enormous set of data sources which can be queried live or be used to model and ingest for detailed analysis and visualization. Brought together with AI capabilities, it's a powerful tool to build and deploy dashboards in the enterprise through rich visualizations and features like natural language querying. Digital transformation and data estate modernization is the topic of the day, and for a good reason. It's here to stay. It's a phenomenon that is actively fueling both the success and the failure of every organization nowadays. Let's dive a little bit deeper into some advanced analytic patterns and let's clarify what they stand for and how they are used. The world of analytics is evolving from the typical descriptive analytics, which is all about what is happening in my business. The data insights provided by descriptive analytics are needed to provide the answer to why it is happening in your business, which is often referred to analyzing root cause or diagnostic analytics. Both descriptive and diagnostic analytics is seen as a workload which is primarily providing a reactive response from what is happening, why is it happening, to what I'm going to do about it. By building out predictive patterns on top of your data, by utilizing the data findings from descriptive, diagnostic, and predictive data, you'll be able to identify what is based on what you get from descriptive and diagnostic analytics, and use to find answers to the question of what is likely to happen in the future based on previous trends and patterns. Prescriptive analytics is a technique to use to provide a predictive insight into your data, and it's commonly introduced by building out machine learning models to predict trends and give the answer to the very interesting question, what might be happening in the future in my business? Cognitive analytics combines a number of intelligent technologies like artificial intelligence, machine learning algorithms, deep learning, etc. to apply human brain-like intelligence to perform certain tasks. Basically, this type of analytics is inspired by how the human brain processes information, draws conclusions, and codifies instincts and experience into learning, such as understanding not only the words in a text, but the full context of what is being written or spoken. Advanced analytics is all about predictive workloads, common scenarios, and usage patterns. It would focus on the trends and prediction of data. There's a few use cases we see across industries. It goes beyond the area of reporting and driving analysis and turn your wealth of data into the ability to predict what happens next. A modern data warehouse lets you bring together all your data at any scale easily to get insights through analytical dashboards, operational reports, or advanced analytics for all your users at the foundation. Advanced analytics introduces, for example, Azure Data to shape the data formats and prep it using a notebook, making internal collaboration on data more streamlined and efficient. Azure Databricks is up to 10 times faster than traditional vanilla Spark. It comes with the approach of a PaaS service. That means you can spin it up, you can shut it down, you can use the pay-as-you-go model, and when you don't need it, simply shut it down. It also comes with capabilities of doing auto pause and other nice features, which we will cover later on during the training. One of the core patterns that customers are using today is the use or need for real-time or near real-time analytical solutions. Real-time scenarios are often more prominent in environments driven by sensors and devices, streaming data services and flows, with the ability to scale on demand and ingestion to real-time or near real-time data pipelines. For example, if you have a paper machine and the paper is a wet mass at the beginning, and at the end you have a big bunch of rolled papers, and the whole thing is a continuous flow. On a machine like this, the machines are bigger than 10, 20 meters long, you have to have the same speed all over the time. If the machine runs too fast, the paper gets too thin. If the machine runs too slow, the paper gets too thick. So the sensor is sending constantly thousands and thousands of informations, and you need to have the capabilities, on the other hand, to ingest the data in real time into a dashboard that someone can react on the wrong behavior. A common architecture used in real-time scenarios is through the use of event hubs or real-time event processing, or even in IoT scenarios by the use of IoT hubs to provide real-time streaming of data and the ability to control and manage the devices. A modern data warehouse lets you bring together all your data at any scale easily and to get insight through analytical dashboards, operational reports, or advanced analytics for all your users at the foundation of a data lake store. Advanced analytics introduces Databricks, introduces Azure Data Factory, introduces Power BI for the real-time dashboarding, and that all together comes with the security mechanism and monitoring mechanisms of Azure and is on an enterprise-grade scalable. Let's now go through a short demo about modern data warehousing and cloud scale analytics. So let me walk you now through a short demo. I have prepared some resources for this demo just to show you what you need if you run a SQL data warehouse or Azure Synapse data warehouse on top of a data lake. If we now go to the resources, we should see, and we see it, we have a Data Factory version 2 installed. We have a SQL Server installed as the basis for a Synapse SQL Pool data warehouse. We have at the same time a storage account created, what will be the basis for our data lake later on. Let's start with the storage account. If you click on the storage account, what you see is that we can create containers, that we can have file shares, we can have tables, we can have queues. We see different tools and SDKs which are available. You can use PowerShell, Azure CLI, .NET, Java, Python, or Node.js. At the same time, if you're part of the preview, you can also use the Storage Explorer. I will walk you through that in a minute. What you see up here is the location. The location for my storage account is Canada Central. I'm using an internal Microsoft Azure consumption subscription. I have read access geo-redundant storage installed, and of course it's the general purpose version 2 data lake. If I now click on containers, what I see is I have 2 containers below that. I have logs and data. If I click on logs, I will find 3 files. This is what I expected to find. I could easily upload more files from here. I could add more directories. So everything I need to do to populate my account here. If I go back to my storage account by clicking on the storage account name, I can go to data, and I see data has 2 files in there. I can also double check the access policies. There's nothing specific done right now. In the properties, what we find is when it was last modified, And we could calculate the size. We can learn a little bit about metadata. So what we would need to do is we would need to set keys and everything in terms of values. If I now go back and enter again my storage account, just briefly want to walk you through what's coming with Storage Explorer. So it's more Windows style. You can click on containers, then you see data, and then again you see the two files we have seen before. You can manage the access directly from here. You can give the POSIX file access or permissions. You could also use a service principal here, what we don't need for our specific purpose. We have nothing in file shares. We could add file shares if necessary. We have nothing in queue and nothing in tables for the time being. The next thing, let's click on the resource group. Now let's have a look at the SQL Data Warehouse. The SQL Data Warehouse is now called Azure Synapse Analytics. The portal also is mentioning that here. So what we see is the status is online, and we also see that there's a pause button, and just for the sake of saving some money, what we will do is we will pause the SQL Data Warehouse. So you see on the right upper corner here that the pause request was received by the database, and as soon as the database is paused, you will see it's paused here. What else can we see here? We could add tags. We see the size of the data warehouse, which in our case is the DW100C, so the smallest version. We see our SQL Server name here, and we see when the next maintenance will be scheduled. Scheduled maintenance is something Microsoft is running. You can negotiate as a customer with Microsoft when is a good time for doing that. As we didn't do any negotiations for our demo purpose, of course, this is simply the next thing what we have here. We can restore. We can have a look at the advanced data security here. We have data discovery as part of that. We have vulnerability assessment and advanced threat protection here. We can switch to auditing and have figure out that for this demo purpose, auditing was disabled. We can go back to the overlook, and we see now the SQL pool is pausing. So yes, if the pool is paused, we have connectivity to the data warehouse itself, but we do not have connectivity to the data. This is something we have to bring up afterwards. When we need the data warehouse again, we simply click on resume, and then it will come up again. As the last thing, we double check if our Azure Data Factory is installed correctly. So if we click on the Azure Data Factory installation, what we find is the name, the location. We find some metrics down here. If we click on author and monitor, what we see is that it's connecting to the Azure Data Factory. It's using my account to do that. We have the name of the data factory here, and this is the starting screen. So what you see here, you find a lot of tutorials, even for SSIS packages, which can be used. There are also other tutorials, like you use Databricks, or you use data flows, or bulk copy with together with Azure Data Factory. What we will have a short look at is in the create pipeline from templates section. What we see here is there's a bunch of pipelines which you could already use, which are deployed and can be used via ARM templates. We can use bulk copy from database to Azure Data Explorer. We can at the same time copy and convert data from Office 365 into common model for open data. We can copy data from on-premise SQL Server to SQL Azure in the cloud. What we get there, if we use that, is the integration runtime, self-hosted integration runtime piece, which is generated for you, and which can be then easily copied to each on-prem machine, server, notebook, whatever, and is then accessing the on-prem data towards the cloud. What else do we have? We have Delta data, which we could even copy from Amazon to Azure. We can copy from Oracle. We can use Dataflow to search log analytics, the built-in analytics of Azure. We can do Delta copies from databases. So you see there's an incremental copy from SAP tables. We have a lot of already prepared templates, which you can use simply by selecting the template. And you could also search for different categories here, etc. So if we just click on, let's say, copy a slowly changing dimension. So what we get here is we get the delimited file. So we could have a look at the Azure Blob Storage for the file. We have the dimension table, which we then select here, which of course we do not have for this demo right here. And what we get is a data flow, which is loading this specific file directly to the wanted table. If you have a look here, transformations with Azure Databricks, so you get the pipeline built up here. So what you get is, what you have to type in is the blob storage or the connection where the data set sits. If you have more data sets, you can add more data sets. You can have the destination file set. And then you have here to select the Azure Databricks installation, which we do not have for this demo purpose here, and connect to the notebook. And what you then get directly is the whole flow from select the file, copy the file to Azure, and start the transformation within Azure Databricks. So far for the first initial demo here, let's jump back to our resource group and let's take it from there within the next chapters. Digital transformation and data estate modernization, it's the topic of the day, and for a good reason. It's here to stay. It's a phenomenon that is actively fueling both the success and the failure of every organization. Azure Synapse is a limitless analytics service that brings together enterprise data warehousing and big data analytics. It gives you the freedom to query data on your terms using either serverless on demand or provisioned resources at scale. Azure Synapse brings these two worlds together with a unified experience to ingest, prepare, manage, and serve data for immediate BI and machine learning needs. With other words, it's behaving like Office 365 for data. We have taken the same industry-leading data warehouse to a whole new level of performance and capabilities. Businesses can continue running their existing data warehouse workloads in production today with Azure Synapse and will automatically benefit from the new capabilities which are in preview. There will be no migration efforts necessary in the future. Businesses can put their data to work much more quickly, productively, and securely, pulling together insights from all data sources, data warehouses, and big data analytics systems. Azure Synapse delivers insight from all your data across data warehouses and big data analytics systems with blazing speed. With Azure Synapse, data professional can query both relational and non-relational data at petabyte scale using their familiar SQL language at nearly limitless scale. We have deeply integrated with Power BI and Azure Machine Learning to greatly expand discovery of insights from all your data and apply machine learning models to all your intelligent apps. And you can significantly reduce project development time for BI and machine learning projects with a limitless analytics service that enables you to seamlessly apply intelligence over all your most important data on one data model from Dynamics 365 to semi-structured data in Office 365. Azure Synapse also provides a unified experience for data prep, data management, data warehousing, big data, and AI tasks. Data engineers can use a code-free visual environment for managing data pipelines. Database administrators can automate query optimization. Data scientists can build proof of concepts in minutes. Business analysts can securely access datasets and use Power BI to build dashboards in minutes, all while using the same analytics service. Unmatched security is part of Azure, and Azure has the most advanced security and privacy features in the market. These features are built into the fabric of Azure Synapse, such as automated threat detection and always-on data encryption. And for fine-grained access control, business can ensure data stays safe and private using column-level security, native row-level security, column-level encryption, as well as dynamic data masking to automatically protect sensitive data in real time in the environment or workspace.
Hello, my name is Rüdiger Schickhaus. I'm working at Microsoft in the Global Black Belt team and responsible for advanced data and analytics. I appreciate and welcome questions during my presentation, but please realize that not all your questions might be addressed, so I might defer you to the question and answer session at the end of this presentation. Our next chapter is dedicated to ingesting data for analytic workloads. We have several topics we want to cover there. First of all, what is Azure Data Factory? How do we ingest data? And then finally about the monitoring. I will also show you a short demo which should help you to understand the different components of Azure Data Factory and how Azure Data Factory is working. What is Azure Data Factory? So let me dig in what Azure Data Factory is. How many of you may have used Data Factory so far? Let's dive a little bit into that whole thing. Data Factory is a cloud-based ETL and data integration service that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. Using Azure Data Factory, you can create and schedule data-driven workflows, we call that pipelines, that can ingest data from disparate data sources. You also can build complex ETL processes that transform data visually with data flows or by using compute services such as Azure HD Insight, Hadoop, Azure Databricks, or Azure SQL Server. Azure Data Factory comes from the orchestration part, but Azure Data Factory also gets, meanwhile, a component which is called data flows, which we will cover later on in this section as well. Let's have a look at the Azure Data Factory process. First of all, we have several steps which together makes a whole complete process. The first step is making a connection to your data sources. You define the connection to the data sources. You add connections to data sources. Typically, this is an easy task because Azure Data Factory comes with more than 90 different connectors, which allows you to connect to various different sources. And typically, you should be able to connect everything you have. By either using native ADF functionality,
making call to external compute resources, for example, a stored procedure in Azure SQL database, or to a model in machine learning services, or through the integration of SSIS packages, you can perform transformations that will clean or modify the data. You could also enrich that data, which means that you perform an analysis that augments the data or creates new data. After the raw data has been refined into a business-ready consumable form, load the data into Azure Synapse Analytics, Azure SQL Database, Azure Cosmos DB, or whichever analytics engine your business users can point to from their business intelligence tools. As Azure Data Factory will perform a regular schedule of data movement activities, it's important to get a monitoring solution in place to ensure you keep on top of any errors or issues that may occur in the day-to-day running of the solution. Let's have a closer look to the components of Azure Data Factory. First of all, there is a feature called linked services. Linked services are much like connection strings, which define the connection information that needs for Data Factory to connect to external sources such as Data Lake Store or Azure Databricks. Think of it this way. A linked service defines the connection to the data source, and a dataset represents the structure of the data. For example, an Azure Storage linked service specifies a connection string to connect to the Azure Storage account. Additionally, an Azure Blob Store dataset specifies the blob container and the folder that contains the data. Linked services are used for two purposes in Data Factory: to represent a data store that includes, but isn't limited to, an on-premise SQL Server database, Oracle database, file share, or Azure Blob Storage account. For a list of supported data stores, see the various articles in the documentation. The second purpose is to represent a compute resource that can host the execution of an activity. For example, the HD Insight Hive activity runs on HD Insight Hadoop clusters. For a list of transformation activities and supported compute environments, see the documentation of transform data in the documentation of Azure Data Factory. Datasets represent data structures within the data stores which simply point to or reference the data you want to use in the activity as inputs. Activities represent a processing step in a pipeline. For example, you might use a copy activity to copy data from one data store to another data store. Similarly, you might use a Hive activity which runs a Hive query on an Azure HD Insight cluster to transform or analyze your data. Data Factory supports three types of activity: data movement activities, data transformation activities, and control activities. A data factory might have one or more pipelines. A pipeline is a logical grouping of activities that performs a unit of work. Together, the activities in a pipeline perform a task. For example, a pipeline can contain a group of activities that ingests data from an Azure blob and then runs a Hive query on HD Insight clusters to partition the data. The benefit of this is that the pipeline allows you to manage the activities as a set instead of managing each one individually. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. Triggers represent the unit of processing that determines when a pipeline execution needs to be kicked off. There are different types of triggers for different types of events. A pipeline run is an instance of the pipeline execution. Pipeline runs are typically instantiated by passing the arguments to the parameters that are defined in pipelines. The arguments can be passed manually or within the trigger definition. Parameters are key value pairs of read-only configuration. Parameters are defined in the pipeline. The arguments for the defined parameters are passed during execution from the run context that was created by a trigger or a pipeline that was executed manually. Activities within the pipeline consume the parameter values. A dataset is a strongly typed parameter and a reusable, referenceable entity. An activity that can reference datasets and can consume the properties that are defined in the dataset definition. A linked service is also a strongly typed parameter that contains the connection information to either a data store or a compute environment. It also is a reusable, referenceable entity. Control flow is an orchestration of pipeline activities that includes chaining activities in a sequence, branching, defining parameters at the pipeline level, and passing arguments while invoking the pipeline on demand or from a trigger. It also includes custom state passing and looping containers that is for each iterations. Variables can be used inside of pipelines to store temporary values and can also be used in conjunction with parameters to enable passing values between pipelines, data flows, and other activities. Finally, integration runtime. Integration runtime is the engine where all the pipelines and control flows will run on. There is a kind of dependency between the different components. A dataset consumes an activity. A pipeline is a logical grouping of activities, and a dataset represents a data item which is stored in a linked service. At the same time, an activity can produce either datasets or can run on linked services. As we described the components of Azure Data Factory, let's have a closer look at the data integration process. Let's have a look at an architectural diagram of a data transformation process with Azure Data Factory. You probably can think about many business processes that have been the need to ingest data files, log files, for which we can use Azure Data Factory loading flat files into Azure Data Lake Store, which could then be the source for a load process into the data warehouse in Azure Synapse. The connect and collect process is key to the Azure Data Factory copy activity, which we'll configure and run in a demo later. The copy activity process reads the data from the source and is executed through the integration runtime. The runtime itself performs a serialized deserialization process, compression, decompression, and the column mapping. These steps are performed based on the input configuration of the source dataset, the output dataset, and execution configuration set in the copy activity. The data then gets written to the destination, often referred to as sink. The copy activity is executed on an integration runtime. Different types of integration runtime for different data copy scenarios are available. When you are copying data between two data stores that are publicly accessible through the internet from any IP, you can use the Azure Integration Runtime for the copy activity. This integration runtime is secure, reliable, scalable, and globally available. When you are copying data to and from data stores that are located on premises or on a network with access control, for example, an Azure Virtual Network, you need to set up a self-hosted integration runtime. An integration runtime needs to be associated with each source and sink data store. It's easy to get the self-hosted integration runtime generated by Azure Data Factory when you need it. To copy files using the copy activity, Azure Data Factory supports a set of supported file formats, which can also be compressed, decompressed using the variety of codecs. Those file formats are text, JSON, Avro, ORC, Parquet, and the different compression and decompression codecs you can use is gzip, deflate, bzip2, zip, deflate. So let's put this all into reality and let's show how Azure Data Factory is working. So we are now back to our environment from the session before. You already know that screen, and I will now walk you through several exercises which should help you to understand how Azure Data Factory is working. The first thing is we want to add the copy activity to the designer. Therefore, we click on our Azure Data Factory. Then you already know we have to go to Author and Monitor. That brings us into Azure Data Factory canvas. Takes a short while to load, but as soon as we're in the canvas, we're already here. And then to make it easy, either you click directly on Author, or if you're not sure and you can't really read it, you can expand that column and then you click on Author. The next step is that we want to create a pipeline by selecting the plus sign, and then we click create on pipeline. So what we have now is the default name pipeline 1. We have all the activities which are possible for a pipeline. We have parameters, we could set variables, we can define output. So first of all, we name that pipeline simply copy activity 1. Not very generic. The next thing is that we have now also the next thing is that we need to add the copy activity to that pipeline. Therefore, we go to Move Transform. We could also integrate other stuff like Azure Functions. We could integrate Databricks directly here. We could integrate notebooks. We could integrate HD Insight, Hive, or MapReduce, or Spark Streaming, and as well as typical ETL stuff like a switch or whatever. So for today, what we want to have is the copy activity. We drag and drop the copy activity into the canvas. So what we now see here is we can fill out the source. We can fill out the sink. They are marked with a 1. So that means that we need to define that afterwards. We could select stuff here. We could add new stuff. We have the mapping available. We could import schemas if we have them. We have additional settings like how many data integration units we want to have. We keep that as auto. We could select the degree of parallelism. We could select the behavior in terms of fault tolerance. So if the activity fails, what should be done? For example, abort the activity on first incompatible row, and we could enabling staging.
So what we will do now is we will ingest data into the data warehouse by using the copy activity. The first thing we have to do is we add a copy activity and we create a new data source. So what you see here is a bunch of data sources which are available. You name it, you got it. Cassandra, can be DB2, can be HDFS, can be MySQL. All the SAP connectors are available, so more or less we have 90 plus connectors available. What we want to have is the HTTP connector. We click on continue. What we want to select here is the delimited text file. We click on continue. We give a name for this text file. We call it here HTTP source. Next is we choose a linked service. We didn't create one, so we just select new. The linked service name is HTTP server 1 for now. What we have to give is the base URL, and the authentication type in our case is basic. We could choose other authentication types like Windows, client certificate, etc. So we stay here for the moment with anonymous, or anonymous. And the next step is that we enable certification validation, and then we click next. We select our services. We have the name HTTP source. We select first row has header, and we could select import from sample file, but in this case we want to choose the import schema from the connection. We select the get method, and then we are more or less done here. We could choose some advanced options, but for this basic example, we are ready. We click on OK, and so we are more or less done with everything. We have defined the source. We have the request mode is get. We have done nearly everything on the source side. We can click on the preview button and have a short preview of the data, so we can see if everything is correct, if we read the correct file and the correct amount of data. So the other stuff we had here were additional headers, or we could request body, and that's more or less it from a source side.
So let's proceed with our demo. Here we have created the source, we have created the pipeline, we have added a copy activity to the pipeline. The next step now is that we create a dataset sync. Therefore, we click on the sync tab. We want to create a new data sync. We want to put that in a data lake Gen 2. And we want to have a delimited text file format again. We keep that as delimited text 1 for now. We create a new linked service, and this linked service name is Azure Data Lake Store 1. We want to have connection via integration runtime. We keep account key. We take this account selection from our Azure subscription. In this subscription, we select our storage account name, and then we have more or less everything we need that we can click on create. Once the resource is created, it gives us a message that it's stored. The next step, which is necessary, is now that we give the file path. The file path should be named data in our example here. We want to import everything from the connection store, and we have selected again the first row is a header. Last step is clicking on OK, and what we now have is we have pipeline. We have a copy activity added to the pipeline. We have added a source and a sink. We could do some selection here if necessary in terms of copy behavior. If you have several files, you can merge them directly into one. You can select the concurrent connections, quote text, and the file extension. At this point in time, we have fully configured our copy activity. Now we want to test it out. To do so, we click on the debug button in the top here and wait till the activity run is starting. It's running now. You see the screen change. We can click on output, and we have the copy activity down here where we see when it was started. We can look on the input. We can have details there. Right now, it's already succeeded. We can have a look on the overall runtime, what's happening there. We had one activity run. We had no self-hosted runtime integration. Pipeline execution was, a little bit more than a second, etc. We can close that. So what we have seen now is that the activity was running. It was copied something. We see that copy data gets this green checkbox. What we, of course, want to do is we want to verify, and let me just go back and show you how I get there. Let's go to our storage account. Let's use this time the Storage Explorer. And as you might remember, we had this containers and we had this data container. And what we have here, and you see this is the last run at 5:02. And what we have here is the new file which we created. It was written to the desired directory. We were not very smart by choosing the name. Definitely, this is something you should do when you use this whole environment. So what we have done now is we have created a copy activity, have added this copy activity to a pipeline. We have created a source and a target, and we have at the same time connected to a data lake, Gen 2. We have started the copy activity, and we could figure out that we have seen the file which we wanted to copy from a HTTP source to an Azure Data Lake Gen 2. As you have seen in the demo, you can easily monitor the copy activity run and monitor subsequent execution during the Azure Data Factory author and monitor in the UI or programmatically. Let's now have a little bit a deeper dive into monitoring data ingestion. To visually monitor the copy activity run, go to your data factory and then go to author and monitor. On the monitoring tab, you see a list of pipeline runs, which with a view activity run button in the action column. Select the view activity runs to see the list of activity runs in the pipeline run. In the action column, you see links to the copy activity input, output, errors if the copy activity run fails, and details. Select the details button in the action column to see the copy activity execution details and performance characteristics. You see information like volume, number of rows, number of files, or data copied from source to sink, throughput, steps the copy activity goes through, with corresponding duration and configurations used for your copy scenario. This is a deeper look on a typical scenario on a typical Azure Data Factory monitoring page. You have a lot of succeeded runs, you have a lot of failed runs for whatever reasons. So if you're interested in what is going on here, click on the action side, and then you go into the next page where you can see what is really going on behind the scenes and gives you a good and deep understanding what is happening in your whole data processing environment. I also would like to give you a deeper look and a deeper understanding of the security in Azure Data Factory. Therefore, we have to start with the credential management of the linked services. So credential management is done by Azure Data Factory. So you have data store, compute linked services where you typically have everything to type in, either username, password, or service principal, or whatever you are using to get access. The integration runtime types below that is the Azure Integration Runtime or the self-hosted integration runtime. So the credential store location for Azure Integration Runtime can be on cloud, being encrypted by Azure Data Factory, or it can be located in the Azure Key Vault. Both options are available. For the self-hosted integration runtimes, you can have the on-premise location. That means encrypted using something like Windows DPAP, or you can use it on cloud. Then it's encrypted by Azure Data Factory, or you can again use the Azure Key Vault. Here you have three options to use. Let's have a closer look at network topologies with ExpressRoute, which is one of the standard methods to connect your on-prem environment to Azure. On the on-prem side, you have your data store, you have the ExpressRoute in between, you have the peering location, which is then talking via the integration runtime, either self-hosted or not self-hosted. And this then gives you a command channel to the data factory in cloud. And there you have then the data channel as well available to the Azure Managed Storage Services. Everything is inside the integration runtime, and the data the storage services are inside the Azure Virtual Network. The data store on-prem is inside the corporate network with your typical corporate firewalls in place. If you are using VPN, you have a similar topology, except that the data store and the integration runtime is inside an Azure Virtual Network. The data factory is connected with integration runtime, and the integration runtime also connects to the Azure Managed Storage Services. How is a VNet looking like? A VNet contains the self-hosted integration runtime on virtual machines. You can have read-write requests to the IS storage, to SQLDB, to Azure storage, or you have a command line channel to something like HD Insight. All that is inside the VNet. The control channel for orchestration is using outbound HTTPS. The data store is accessible from inside the VNet using service endpoints, and the command channel is for dispatching transformation activities. Let's summarize what we have learned in the last section. Azure Data Factory is a cloud-based data integration service that allows you to orchestrate and automate data movement and data integrations. Data Factory comes with two parts. The first one is the orchestration part, where you can orchestrate various different flows and various different tools to run data flows, which are then doing the ETL part. Ingesting data can be performed by Azure Data Factory copy activity. The Azure Data Factory copy activity can be used to connect and collect data for ingestion and to publish data to BI tools and applications. A copy activity typically does not include a lot of ETL. If you want to use ETL, then you have to use Azure Data Factory flows, data flows, which gives you the full set of transformation capabilities like joins, like merges, like Derive columns, and all that stuff. Different integration runtimes are required for different ingestion scenarios. You can either have an integration runtime, which is connecting cloud to cloud, for example, or you can have a self-hosted integration runtime, which connects your on-prem environment into the cloud. It's typically just in that direction. File copy are very efficient using the Azure Data Factory copy activity, and it's very simple to create those file copy activities. You can use the Azure Data Factory wizard to copy from various different systems to various different targets. You can monitor the performance of the Azure Data Factory copy activity both visually and programmatically, as you have seen in the different slides.
Hi everyone, and welcome to today's session, Transforming and Enriching Data. My name is Andre, and I'm a part of the global Black Belt team. I'm a tech specialist, and I'm covering data and AI domain across EMEA. And today we're going to talk about how to transform and enrich your data using various techniques and various tools, including Azure Data Factory, Azure Synapse, and others.
In a nutshell, Azure Data Factory is a cloud-based data integration service that allows you to orchestrate and automate data movement and data transformation.
So in fact, you can use Azure Data Factory not only to perform ETL, typical ETL operations, like grab the data from one source, transform it, and put it into another source, but also as an orchestration engine which will allow you to put things in order and create different flows like a happy path or unhappy path, or what will happen in different situations. You can create conditions and you can pretty much take control over the data transformation at scale. But in addition to that, you can also control this flow not only in the cloud or on-prem, but across different environments and different runtimes, such as self-hosted runtime or Azure Databricks or Azure Runtime, and we're going to talk about that in a bit.
So let's talk a bit on how that works. So in Azure Data Factory, the process of working with Azure Data Factory consists of 4 major steps. At the first step, you collect the information from the source. In order to do that, the metadata from the source specifically. In order to do that, you connect to this source of data, which might be HDFS or some file system or some database or even the REST service, for example. After that, you define the set of steps which you use to transform and enrich your data and how these steps follow each other, how they're interconnected. When these steps are defined, it might be anything. It might be copy data, it might be running a machine learning model, it might be running some Spark job or something else. After you do that, you publish this, right? So you're publishing these steps combined in so-called pipelines into the service itself, so you can start and you can trigger that. And when you trigger that service, you can go directly to the monitoring and checking how that works. Let's talk about Azure Data Factory components, from which components it consists. So the first component is a linked service. Linked service is a container which defines to which service or database we do connect. So for example, it might be a data lake, Azure Data Lake Store, for example, or Azure Databricks, or something else. We have more than 90 connectors to different services. After the linked service is defined, we have the concept of the dataset. And the dataset effectively is something which is implemented on this service. So for example, it might be the location in the Azure Data Lake Store, or it might be a table into the database, or set of tables into the database, right? So this represents the dataset. After the data set is defined, we know and we see that there is a data in link service and we can read it. We define and run some activities. Activity is a unit of work which is executed in order to get the result. So activity might be a copy, for instance. It might be something else, something much more sophisticated, like calling the Databricks notebook, for example, or executing some custom code. And these activities can be tightened together into the control flow, so-called control flow, which allows you to say that this activity is executed after another activity on success, for example, on failure, or on incomplete of the activity, for instance, right? And then you can combine these activities into the pipelines, which effectively hold activities together and are monitored and executed as as the same set of activities. So pipeline can be triggered, and this trigger might be the time, or might be ad hoc, or might be a timed window, for instance, or it might be even an event, like the data appears in data lake store. So when the pipeline is triggered, it's being executed, and we can transform one data set into another data set, for example, right? So we can, for example, take data from link service and put it into the data set. And once again, link service and the data sets can be both on the source and on the sync side, right? Also, we do support parameters, so you can build some more sophisticated and parameterized pipelines and activities. So you don't need, for example, to build 100 activities for 100 tables. You can parameterize that. Also, we do support the integration runtimes, which represents the physical compute or virtual compute where these pipelines and these activities will run. And we have several different approaches for the integration runtime. And then we have the control flow, which we discussed. It's basically the structured set of activities executed one after another under certain conditions. So once again, just to recap, we have the pipeline, which is a logical grouping of activities. And on the pipeline level, we do the scheduling, monitoring, managing, we do the DevOps integration on the pipeline level as well. And it's a logical grouping of activities. Activity can be calling the stored procedure, copy, some Hive activity, whatsoever, and activity runs on the link service. So for instance, link service can be SQL Server, Hadoop cluster, HDFS, something like that, right? Activity produces and consumes the data sets like tables, files, and so on. And data set represents a data item like table or file stored in link service. One thing we need to talk about is the Azure Data Factory orchestration at scale. The beauty of Azure Data Factory is that you can divide the the physical execution into the different integration runtimes which run in different environments. So for instance, you can use the self-hosted integration runtime, which effectively is an application which you install on your virtual machines or physical bare metal machines, and which you use to run some of the activities on, right? And basically what you can do, if you have something which sits in your HDFS in the secure zone, then you can copy that into some intermediary location, and then from this intermediary location you can copy that into the cloud, for example, or do some pre-work, pre-analysis, or some additional enrichment, and it will be done physically in your on-prem environment. And then in the cloud, you can define some different activities which will be executed either on the success, the green line, or on failure, the red line, right? And these activities will be executed on the integration runtime provided when this activity is started, provided by Azure when this activity is started. We also can combine pipelines into the set of pipelines and even do a fan outs or do the pipeline as a result of failure of another or success on another pipeline. Right? Also, the interesting thing is that even though within this pipeline, we distributed some activities to the self-hosted runtime and other activities into the Azure runtime, they will be monitored and triggered and managed in exactly the same way, right? So regardless of where it runs, it's just an assignment of where it's being executed. We were talking a bit about the connectors, and we have 90 plus connectors out of the box, which covers most of the popular Azure services, which covers most of the popular databases and data warehouses, like Oracle, for instance, or MariaDB, MySQL, SQL Server, right? Or something like more specific, like Drill, for instance, or Phoenix, right? We do support some file storages like HDFS, but also we support the other cloud provider services like S3 or Google Cloud Storage. We do support 3 most popular NoSQL databases, Cassandra, Couchbase, MongoDB, and we do support some services and apps like, for instance, Magento, right, or Jira, or Dynamics, or Concur, for example, PayPal, right, or Salesforce. And we do support some generic calls, which you can use to connect to the data sources, which are not represented here, but also to connect to the web services. In terms of the activities, we do have some activities like Move and Transform, which are the Azure Data Factory native activities. One of those is data flow. We're going to talk about that in a bit. We do support some custom code, for instance, Azure Functions. We do support Databricks, calling the jar or Python code or notebook in Databricks. We do support some general activities like we can combine pipelines together, for example. We can execute SSIS packages if you already have something like that. We can do lookups, calling stored procedures, and so on. We do support integration with HD Insights, which can be Spark on streaming or something like Hive, for example, right? And we do support some conditional or switching, or let's say for each statements within the pipeline. So you can do the copy for each parameterized copy for each table out of 100 tables, for instance. And we also support the machine learning like batch execution or ML pipeline execution.
So this combination of different, more than 90 connectors, in fact, to virtually all the most well-known database and data services, as well as the combination of vast variety of steps and different runtimes, allows you to create very optimal and very sophisticated approaches for the working with data. But also with something like data flows, you can achieve similar things without writing a code, and it will be working very fast and reliable.
Transforming data with the ADF mapping data flow. Let's gonna talk about different ways of how we can work with the data. Data transformation in Azure, if we can talk about that in some examples, let's say, or some reference architecture, we can think about different aspects, let's say, right? So we can say that logs, files, like some unstructured data is handled by Azure Data Factory, and we can load these flat files into data lake on schedule, for example, right? And we can use this data lake as a storage. On the other thread, we can use also ADF for data preparation and data extraction from the transactional storage, where we store highly structured data, right? And then from Azure Data Lake storage, we can load data directly into Synapse Analytics, which will act as a serving layer for our Power BI dashboards of applications. But also, we can read data from Azure Storage, do the extensive data preparation with Databricks, and do load that into Azure Synapse Analytics. So that thing with Azure Data Factory, like combining with data storage and Synapse Analytics, is a transform and enrich part. There are several methods for transforming data in Azure Data Factory. One is the pure compute resources. So you can use Azure Databricks as a compute resource, or you can use HD Insights as a compute resource. Another is to run SSIS packages, pretty much like you would do that in the SQL Server world, and run them on Azure Data Factory. And another one is to use the newer functionality of Azure Data Factory, such as mapping data flow, for example. We're going to talk about the mapping data flow in a little bit more details, because it's a code-free data transformation tool.
So let's talk about the Azure Data Factory mapping data flow for a bit. Azure Data Factory mapping data flow as a tool which was announced around half a year ago, and which allows you to create the transformation flows between the source and the sink without any code. And it allows you to do many different and very well-known operations such as joins, filters, selects, and some splits and so on based on the condition without writing a single line of code, which is pretty powerful concept.
There are several benefits of using mapping data flow. So first of all, it's a code-free data transformation at scale. So you can do data cleansing, data transformation, some aggregations, and so on. Also, it enables you to build resilient data flows in a code-free environment. So you don't need to run any code. You just need to, if you need to do some data transformation, basic data transformation at scale, you can do that with mapping data flow without writing code. And also it enables you to focus on building business logic and data transformation logic instead of running and testing the code. And underlying infrastructure is provisioned automatically with cloud scale by Spark execution. So basically the mapping data flow behind the scenes is executed on the Spark. And to work with it, you really don't need to have any coding skills. So let's talk about the using mapping data flow. So when we're talking about the different types of resources and how we can create different data factory resources, we can create pipelines from templates, data sets, and data flows as well. And data flow is basically a graph in the middle, some configuration settings in the bottom, and some debug settings and validation in the top bar, right? So, and here you can just click and create some more sophisticated execution, right? And when you create in the pipeline, you can define data flow as an activity and put that as a part of the pipeline and execute that. So creating new data flow, it's pretty straightforward. You can just add the source, first of all, or several sources, and then add different steps. And we're going to see that in a demo in a moment. And then different steps for the transformation logic, and then end up with a sink. So there are several transformation options in the data flow. It's union, join, it's sync, it's a pivot, conditional split, and so on. So there are a few of the transformation options, very interesting ones you can use to transform your data. And basically, to do that, you just need to click here and add these one of these or many of these steps to the source and then sync it to the sink.
So let's talk a little bit about triggering and monitoring. Triggering is a part where ADF has a certain capabilities, like trigger based on the time, particular time of schedule, based on a time window, or even based on the event, like objects are ingested in a certain area of your Azure Data Lake storage, for instance.
Triggering the pipeline is pretty simple. So if you already have the pipeline with the data flow, for example, you can just click the trigger and say trigger now. Or you can create a new trigger with a schedule, with a tumbling window, or with an event, right? And you can define the date, the recurrence of this trigger, and then when it ends, and so on and so forth, and if it's active or not. After the pipeline is triggered, you can go to the monitoring pane, and then you can see all the pipelines you have and view their activities, and you can see whatever is success or failure. You can go to the logs and so on and so forth, right? Let's talk a bit, before jumping to the Azure Data Factory demo, let's talk a bit about transforming data in Azure Synapse. There are several ways of using Synapse to transform the data which sits, for example, in Azure Data Lake Store. One of these approaches is to use a copy command. The example is here to the right, so we can say, okay, we can just get the data directly from this endpoint, which is blob, with a certain parameters, with a certain file type, with certain access to this blob, and with a certain format. And then we can just copy this data into the table we have. And if we have, for instance, something like Parquet, the file format definition will be much easier and simpler. And you can just grab this data directly from location, which might be a file, multiple files, right, into your table. And we support CSV, Parquet, or C file formats as a copy command. Also, what you can do, if you already have there is another concept of external tables in Azure Synapse. Basically, if you have the defined credentials and file formats and the sources, you can do, in fact, offloading of the tables which are already in Synapse into the files. So you can say create external table with location and as select. So basically you can grab the data from your query and basically transform that into the file and put that back into the ADLS and then consume that back with, let's say, with a copy command or whatever. So it allows you the bulk way interaction from data warehouse into ADLS. So let's have a short demo on transforming your data in Azure Data Factory. So to make this more visual, what we just discussed about the Azure Data Factory, we're here, it's in the portal, and it's a control plane for Azure Data Factory as a service. And there are some things we can see. It's like endpoints, what's the version of this data pipeline, right? Data Factory service, some activity logs, access controls, and some other metrics, which is not that much, right? But if we're going to click author and monitor, we're going to jump into here. And basically here we can see the authoring of the pipeline and how it looks like. So typically, let's just go through what we discussed and make it visual. So we discussed the connections, and there are certain services we can connect to. We can connect to whatever is there out of these 90 connectors, right? For example, to blob storage or to databases and so on and so forth. And then we have these linked services. Then we can create the triggers, and these triggers can be a schedule, it can be tumbling window, let's say every 15 minutes, or schedule at a certain date, and then how often it recurs. And then we can do the even events if something is added into this, let's say, into this container, then this pipeline will be triggered, right? So this is triggers. So then we can say, okay, we have the data sets, and this data set might be the CSV file or might be the folder or table or whatever. And here we can see that it has a linked service. So basically, it's connected to this linked service. We can see the path or what it is exactly. We can see the format, and then if it's defined correctly, then we can preview the data which is in there. And we also can see the schema, and we can define some additional parameters if you want to. So it's a data set. When it comes to the pipelines, what we can do here is a simple pipeline with just one activity, which is a mapping data flow, and we're going to talk about that in a bit. But also what we can do and how we can orchestrate a pipeline, for example, we can say, okay, we do the copy data, and then we do on success of this data copy, we do some transformation, and if this transformation is successful, so we assume that the data sits somewhere, we can execute the new pipeline, for example, right? Or if this transformation wasn't successful, we can execute another pipeline, which is a control flow, right? Or for example, if we want to process some skipped rows just to do some analysis of that or something else or some logging, then we can execute some other pipeline. So basically we can structure these pipelines and combine them together and do this, create these sophisticated control flows. So so basically when we are talking about the data flows, then we have the separate resource which is called the data flow, and here we can see this data flow, right? So for example, we have some sources here, and basically this source just represents the data set, in fact, right? And this source has certain options and it has certain projections, so we can define the format. It can do some optimizations because underlying engine is Spark, right? We can repartition that, right? And we can do some inspection of order and so on, and we can even do the data preview here. And then with these data sets, we can do a bunch of different things. So for instance, we can join this data set, right? Or and basically we have the full outer join here for 2 columns, and then what we're doing in this example, we're just removing some of the columns. So here there was 9 columns, 3 were removed, and then we're joining these once again with another data set, right? And just removing some of the columns once again, adding enriching data from 6 to 7 columns, so we're adding some extra, and then sending that to the sink. And this specific data flow is just one piece of the data pipeline, which might be larger or might have longer execution and longer control flow. And then when we're just saying trigger now, or like when we're triggering that, our pipeline starting the execution process, right? And we can monitor basically this execution process here. We can see the pipeline runs, we can see trigger runs, we can see the integration runtimes we're working with, and so on, right? We can rerun the pipeline from here, for example, and within the pipeline we can see some detailed execution statistics, for instance, for this data flow. So how fast it will sync, how many objects or rows were read or kind of joined, and so on, how fast that was done, if any failures were occurred, and so on and so forth. So basically these are the main concepts. And also, if you want to start with a service, there are some getting started guides and really nice wizards which can help you, especially when you need to do the parameterization. One more important point here is that the entire pipeline is defined as a code, so it's not only can be parameterized, but it also can be put under version control, like Git integration or DevOps integration, and it also can be treated as a code, including tweaked and so on. So in summary, Azure Data Factory is a cloud-based data integration service, and it allows you to orchestrate and automate both data movement and data transformation. It can be performed with different approaches, let's say by orchestrating compute resource, calling SSIS packages, or using mapping data flow, for example. Mapping data flow enables code-free data transformation at scale, and it enables you to focus on the building business logic, not the building the code. Right? It's added to ADF pipeline and can be scheduled and triggered, and you can monitor the mapping data flow both virtually and programmatically.
So, we have discussed the different options and approaches for data transformation with Synapse Analytics, and we have paid a lot of attention to Azure Data Factory. And in summary, in conclusion, I can say that Azure Data Factory is a very robust and reliable tool which can be used for a variety of purposes, which can allow you to bring the data to the cloud, transform it, and work with it without writing a single line of code, which sometimes it's really important, especially in kind of the first projects or when you need to move fast.